In order to group by day, we'll need to adjust all the times on April 1st, 2017 to read 2017 04 01 000000. That way, when we group by date, we get every event that occurred for all hours, minutes, and seconds of April 1st. They'll all be grouped together into the same grouping. We can do this using the dateTrunc function.
Let's start by grouping by occurred at without any truncation. As you can see, this doesn't help us much at all. If we replace each instance of occurred at with a truncated version, we'll get a result set that sums the quantities of standard paper by day. It's important to group by the same metric that's included in the select statement to assure your results are consistent. In some databases, it's possible to group by a year but truncate on day in the select statement. This is something most people only do by accident, as it provides results that are confusing and, in many cases, wrong for the type of question you're trying to answer. The easiest way to make sure you group correctly is to use column numbers instead of retyping the exact functions.
dateTrunc can be used to aggregate at very granular levels, like second. That might be useful if you're working with server logs where many events happen in a given second. Most of the time, though, you'll use this to aggregate at intervals that make sense from a business perspective: day, week, month, quarter, and year. Here we can see different truncations. Notice that if our month or day are 0, 1, there's no change made to these values, as you can see. There are some cases where you might want to just pull out a given part of the date. For example, if you want to know what day of the week Parch and Posey's website sees the most traffic, you wouldn't want to use dateTrunc. To get the day of the week, you'd have to use datePart. datePart allows you to pull the part of the date that you're interested in. But notice that regardless of year, a datePart would provide the same month for an event that happens in April 2016 and April 2017, where a dateTrunc would differentiate these events.
Let's explore this example using Parch and Posey's data. On what day of the week are the most sales made? Let's start by figuring out the day of the week for each order. DOW stands for day of week and returns a value from 0 to 6, where 0 is Sunday and 6 is Saturday. Now that we have this column, we can aggregate to figure out the day with the most reams of paper sold. We'll order it by the sum in descending order so that the day with the most sales will be at the top of the result set. Looks like the most paper was ordered on Sunday, and the least paper was ordered on Thursday.